we will be talking about this tenant routed multicast. And today's session, I have molded it like in such a way where we will see BGP differently. And before I get into this discussion, before we get into the specific address families, today's session, we will just be setting some base. I will be introducing some new route types to you guys. We will have this comparison of PIM with BGP. Now, they are completely different things. So you may be wondering, like Sunil, what we will compare. But here, I want to give you an analogy also. Some of you were there in these eVPN sessions also. Why eVPN came into picture in the first place? Because there were certain problem with VPLS. Okay, we all know that's a technical answer. But if we go one level below this, there was this Ethernet, and this Ethernet had certain behavior, like the way it walk. And industry peoples, they thought that it may be cumbersome to change anything in Ethernet now. In fact, sometime back, we were struggling for one innovation and we submitted it. The committee liked that idea that, oh, this is brilliant. This is something which is good. I can't expose that for now, but or disclose it. I think disclose is the right word. I can't disclose that now, but the feedback that was given to us is this. So that innovation was something on the VXLAN side. And what these guys said that this VXLAN is already an industry standard, and that there are as such no dedicated standard bodies which are working on VXLAN right now. So changing something in the VXLAN will be cumbersome, though your innovation is good. Basically, we were trying to propose something in that header field of the VXLAN. The same stories goes to Ethernet. Ethernet works on layer 2. Thou layer 3 is perfect, scalable, predictable, but still customer need layer 2, and they were, or when I say they, I'm talking about these industry people, they were not able to change this behavior because this change was huge. They rejected our VXLAN, and if you compare VXLAN as compared to Ethernet, you may be comparing a rat with a big elephant. So changing something on the Ethernet is even big deal. So they said, let's just encapsulate this layer 2 as it is and have something like this encapsulation in the data plane and eVPN in the control plane. You may be wondering, Sunil might have gone mad. We are all here for the multicast. Why we are talking about eVPN, VPLS, Ethernet, VXLAN? The reason is, even though we are introducing PIM, even though we are introducing BGP for PIM, but none of the behavior of the multicast is allowed to change. BGP, if it want to come into the area of PIM to provide something valuable where customers or these industries, they can have BGP rather than PIM, but the functionality that PIM used to provide is a must for BGP. So BGP, it's like a protocol of choice for network engineers. Even I say this, even we are in these AI arenas where 3 months is a very long time for a new innovation to come. Like if we, when we started, Nobody knew this deep seek or something, right? And now it is making so many waves. So the technologies are changing so fast, but certain fundamentals, because their foundation was so strong, are there to stay. And I will prove this point to you guys that when we are replacing PIM with BGP, I will tell you where we are replacing it. But from the end user perspective, from the outcome perspective, BGP should achieve the same goal which PIM was giving to us. Nothing changes there. So walk in this session with this thought process. Okay. So you might have seen that there are so many profiles in MPLS that exist. Does anybody know how many profiles we have for implementing multicast over a SP network, let's say?
I think 29 profile.
Yeah, it's approximately 30 years. So earlier
Yes.
it was 27, and then there were, I think, 2 or 3 added for segment routing. So
Yes.
yeah, so it's actually like in multicast we used to form this tree, right? And when I was first reading about these service providers, all these profiles, it is actually a forest with lot of trees. And then you are there to pick one which suits your requirement. But if we are at a very basic level, let's say, and if I want to give you some fundamental things, this is what you will see. Either you can have PIM here as it is written, you can have PIM here and PIM here. But then these service providers, they said our network is very big. And one more thing here, and then listen to me very carefully here. PIM is a signaling protocol. What does that mean? When the receiver comes online, they signal, they send some signal that, okay, we want something. That signal get delivered to your gateway, let's say. But then that signaling doesn't end there. Gateway send that signaling to upstream, then from that upstream to further upstream, and then till RP. Or if it is SSM, then it is towards your source. But you will see that signaling hop by hop. Even when the source comes online, your gateway here also send some signal. And anything which is based on signals put a toll on the network, because you need to maintain that signaling. One receiver came online, send one signal. 1,000 receivers comes online at 1,000 different places, let's say. How many signaling you will have? And for service provider, believe me, 1,000 is a very small number. So anything which is based on signals, they basically service provider trying to get reserve that, okay, if it is based on signaling, can you suggest me some alternative? And one of the alternative for SP, it's like that cart where they want to dump everything. Whatever problem came, layer 3 customer wanted, dump it on BGP. L3 VPN, now service provider need this L3 VPN, dump it on BGP. L2 VPN, dump it on BGP. So these SPs somehow they were in love with this BGP, and that's where this common question came that, okay, PIM is also a signaling protocol, so much chatty, like every signal that they need to maintain and all that. Can we dump it to BGP? And BGP is like that nice guy who doesn't know how to say no. So BGP said, okay, Let me carry this also. So BGP carry. How BGP carry, I will tell you today. But for now, we are just building up the base. So my aim here is, what was the problem with PIM? And in fact, PIM has another brother here in service providers network that has similar issues. At the high level, it looked very promising, but didn't went that far. Who was that brother? That brother was RSVP, traffic engineering. I myself has been there in multiple presentations, like I'm talking some 8 to 10 years back. Customers were like, yes, this is what we need. I can send certain traffic via some express route in my network. Other traffic I can reroute via some other path. RSVP had all those benefit, explicit routing. From here, take this express route, take this highway, take this toll road, whatever. And whoever cannot pay that toll to the service provider, and when I say toll, I mean the extra money, service provider say that, okay, you take this longer route because my shorter route has limited bandwidth and that is there for premium customers. RSVP just offered it. But the problem, it was also a protocol worked on signals. It signaled the path in the control plane and then it established. Didn't went that well. Same with PIM. So they came up with this alternative that at the end, because you don't change anything on the Ethernet, EVPN also, whatever was introduced only till here. Here, it was same Ethernet. Same way, just replace this E with M. So MVPN was introduced again here only. Here it is PIM, as you see on the slide. That means PIM has to be seamlessly translated to a MVPN, and at the other end, it should again translate it to PIM so that you have this end-to-end flow. We will talk about that. Okay, should be simple enough. Let's just see what text we have. So technical terms, VTAP, your CE, signalization is PIM based, VTAP to VTAP, BGP based. We all know BGP is a control plane protocol, and when you deploy BGP, scalability comes by default. Like L2 VPN, EVPN, there is this new address family that was introduced. Multicast signaling, just take a note of this point. Multicast signaling works differently in BGP than in PIM, but it is the multicast signaling because we are asking BGP to take care of our multicast. Okay, now let's just take a look on this MVPN and let's just see what are different route types. And this is what I often say. In EVPN, what we have done, EVPN said that it can carry this L2 VPN on top of it. Basically, we can extend our L2 VPN over a fabric, over a L3 environment with EVPN. So, and L3 VPN was already there with VPN v4 or even EVPN also. You may argue with me that Sunil, it also support L3 VPN. That's fine. But that's not the point I want to highlight. What I'm trying to highlight, we just asked for L2 VPNs. Service provider, data center, or even enterprises now, they asked for L2 VPN. And to support this, EVPN introduced route type 1 to 5. Total 5 different route types EVPN has to introduce so that it can seamlessly carry that Ethernet behavior, because Ethernet was not allowed to change. So BGP said, okay, let me introduce one route type for particular thing. If it is MAC or IP, route type 2. If it is multi-homing, route type 1, route type 4. If it is layer 3, route type 5. And then there is this route type 3 also for ingress replication. But 5 different route types were introduced just to support this thing, only this thing. Now what we are asking PIM. PIM functionality, multicast functionality. How many route types are there for this? Before I get into this is your L2 VPN, EVPN address family. And this by now you might have guessed only MVPN address family. Okay, so how many route types has been introduced? The first one is, and then I'm keeping it at a very high level, is this type 3. Leave this route for now. If possible, take a snapshot of this. I will come to this route type 3 in a while. But there is this route type 5. Route type 5 is whenever any source comes online, when that source send the traffic to its default gateway, let's say, this gateway, because now we have implemented BGP this side, right? Remember here it is PIM. If previous diagram, if you guys remember, from gateway to gateway, let's say these are all different routers. I'm writing gateway 1, gateway 2, but they are routers. Between these two parts or anything above this line is BGP. So in that it generates this route type 5. I'm just typing RT5 whenever any source comes online. So when a source starts sending traffic, its gateway where it is connected will send a route type 5. Source active. Can you tell me, do we have any such functionality in PIM?
Register message.
Okay. I'm glad you answered this, but for this, there is no equivalent in PIM. I will come to that register message in a while, but route type 5 has no equivalent functionality in PIM. Basically, in PIM, this doesn't even exist. Okay, route type 6. It is a shared tree join. So when a receiver come online, let's say receivers are coming here, what they will send? They will send this IGMP, right? Nothing changes here. But from here, when this gateway receive, if it is PIM, it was PIM joined. But now we have only BGP. Then we will send this type 6 route. Does this have an equivalent functionality in PIM? Answer to that is yes. You have this star comma G PIM join towards your RP. What does that mean? RPs exist even in MVPN also. So rather than that PIM join, that star comma G, that PIM join travel hop by hop, BGP will send route type 6, telling the RP. In this case, let's say RP is somewhere here. This is RP. That there are certain receivers which came online. If no source, it is fine. And what it will result into, when RP receives this, RP will create star comma G entry, the way it used to do with PIM, same functionality. And then your type 7 source pre-join. So when RP know that okay, there is certain source which is online, and how RP will know that there is a source that exists? Lucia just answered it. How does RP knows that there is a source that exists? Because RP might have got some register message. Even though this route type 5 was generated, route type 5 was sent, but this gateway will still send this register message towards the RP. And then RP know there is a source that exists. Once RP know what, when a source exists, what RP was doing earlier, RP was sending S, G joined towards the source. But in this case, because we have MVPN, what it will do, it will generate type 7 route towards your gateway where the source is connected. So type 6, type 7, you have equivalent functionality in PIM. Type 5, you doesn't have. Let's just look at it periodically, and somehow I was not able to build some animation because some part of this is a picture, but you just follow these numbers. 1, IGMP join came to LHR. LHR will generate this type 6 route, that star comma G, right? Because only receiver came online. There is no source, and that will go to RP. Now some source came online, as you see here. It starts sending this multicast stream, and then this FHR will send this source registration, that PIM register message. That will be sent to RP. So once RP received that register message, RP has already received this type 6 route. That means star comma G is already created on RP. There are interested receivers on RP. RP knows that. RP will send this type 7 route source tree towards FHR, first hop router. And when this guy receives this FHR, this type 7 route, what it will do? It will, first hop router will know that okay, there are certain receivers. That's why somebody had sent me this type 7 route. So let me send this type 5 route informing everybody in the fabric that there is this source which is connected to me. When that is sent, LHR, last hop router, will send this type 7 that okay, yes, I want to join this, I want to join this. And when FHR receive this type 7 route, what it will do, it will start sending the multicast stream. I can erase this if you guys want to take a snapshot of it for your reference.
Sunil,
Yeah,
where is the RP located? Because I don't
RP
assume,
is
I
okay.
just mean the route reflector is where you're positioning RP, right?
Yes, RP is somewhere in the fabric for now, just to understand that way. There are certain deployment model for RP. We will come to that, but for now, just understand that RP is somewhere in this fabric.
Yeah, so that's, I wanted to understand that because these messages that keep going up and down, they're going to go via BGP.
Yes,
So the source is going to send something, the receiver is going to send something,
yes,
but there is something there which you are calling the RP now that is overseeing the initial arrangement of all these communication. Once that initial arrangement is done, then allow the source and the receivers to talk to each other directly. That that which is the RP is what I want to understand. What kind of configuration is ought to be there? Sorry.
then basically see it. So as I was saying at the start also, right? None of that basic multicast functionality changes. RP role is still this, that it acting as a bridge for the receivers and the source. So once it connect that, this will be SPT that will be triggered from the LHR side. And then remember, whatever PGP, MVP, and whatever we are talking about is only in the control plane. The data plane still works the same way. When LHR know directly the source, it will trigger that SPT. It will send this directly to the FHR, and FHR will start sending the multicast stream. RP will not come in the data plane at all. And if you give me some more time, there is one more concept that I wanted to talk, but let this get digested, then I will come to that.
Sunil, so in this case, RP will tell the first of router that there is a receiver. So that is the only job for RP in this case. If there is no
Earlier
receiver,
also it was the same job for RP, right? RP know where are the receivers, and then it tell the source that PIM join, it send towards S, G, and your multicast traffic start flowing. So earlier also RP was doing the same thing.
but earlier at least RP will send the first packet to LHR and there will be a shared tree.
No.
So
Packets always sent from the receiver. Remember this thing. Multicast is a receiver initiated thing. Let's say there are no receiver. This FHR, this source comes online. What will happen? FHR will send a PIM register message to RP. RP will see there are no receivers. It will send a register stop and said that, okay, there are no receiver. Stop right there itself. Multicast is always a receiver originated thing. If there are receivers, then only multicast traffic will come. Does that clarify?
sixth step, right? Source at the message. So it will be sent only to. Is it like it will be sent to all the
Whenever,
devices or like?
yes. So when a type 7 is received by the FHR will initiate this type 5 route.
To all the devices except RP.
Well, this is a BGP route, and BGP route will be advertised to everybody, even to the RP, if you have configured BGP there. So even it will go to the RP also. But the node which will act on that is the node where the receivers are connected. But in this case, does that answer, Shobha?
Yes.
Okay, so maybe you can go on mute now. I think some background noise. But you guys might have seen some inefficiency here. Let me just park that. One more thing that I want to talk today, and then let's just talk about some more things. So what we are talking about here is this TRM, let's say, and then by the way, this service provider MVPN. Also, I am running this parallel track. But what TRM or MVPN in NSP do? They take this C packet, let's say customer packet, right? And then they encapsulate it in something. In VXLAN, let's say, then it's a IPv4 header, let's say. If it is MPLS, then there will be some additional labels. But all in all, you take this C packet, and by the way, the C packet is a multicast packet. That means there is some resource, let's say 1.1.1.1, sending to certain multicast group, let's say 2.227.1.1.1. This packet will entirely get encapsulated in VXLAN, let's say. But when it gets encapsulated, what will be the source? What will be the destination? Because it is multicast. So the destination has to be multicast. So the outer packet if we take this, the outer packet source will be your VTAP, let's say 10.1.1.1. Destination will be 239.1.1.1. And then inside you will have this packet here. What is this 239.1.1.1? That is MDT, default MDT that you configure. What is default MDT? Basically, when the packet come here, any multicast packet, it will get encapsulated in this default MDT. I will show you the configuration. It is actually a multicast delivered to all the node. You might have seen some inefficiency here where, let's say, there are receivers only connected here. There is no receiver here and here, but default MDT will still send it everywhere, and these guys have to drop. So this is something which was kind of inefficiency that was there in default MDT. So
MDT has expansion.
expansion means
M stands for something word. Is it an abbreviation?
multicast distribution tree.
Okay.
Oh yeah, we are so used to of these acronyms that we forgot to write the full form. But yes, it is multicast distribution tree. So as you can see that this is something very inefficient. If there are no receiver here, and multicast is a receiver only thing, why the stream should come here? So for that, there was this data MDT which was introduced. So data MDT will send the traffic to only the receivers which are interested. A little bit of advanced concepts. And if you go back to that route type, there was this route type 3. If I show that again, this one. SPMSI AD route data MDT signalization. So BGP signal this route type 3 when it need to switch over to data MDT. Okay, for now, remember this. Yeah, any questions?
Yeah, so may I ask, are we,
Yeah,
if we are supposed to do some like-to-like comparison, are we then saying that in the standard PIM as compared to the tenanted multicast, you would agree that the default MDT is just seen as the shared tree and the data MDT is seen as the source tree?
Well, actually, no. Because shared tree, the concept is different. Shared tree, the root is RP. So everything will travel towards RP. But in default MDT, so it understand it like this, right? Or let me go here. TRM packet encapsulation. So first of all, what we are trying to do here, let me just draw a fabric here. Okay, a simple 3-node fabric. Okay, so this is my spine. These are leaf. I'm writing L1, L2, L3. They are not layer, they are leaf. Okay. There is a source which comes here. Let me draw that source in red. So there is a source which is connected here. And there is a receiver which is connected here. What they will do, they will send certain traffic. Let's say this guy is sending some 10.1.1.1 is the IP, and it is sending traffic to 227.1.1.1. And if I come back to my fabric, this side above, right, it's a VXLAN fabric. VXLAN is encapsulation. That means the packet which is coming from here, it will encapsulate that entirely in a different packet, multicast packet. And then it said that, okay, that packet which get encapsulated, it will send to all the leaf interfaces of that VNI. You were there, Amas, in the eVPN session. We talked about this VNI, L3 VNI. That means in that, with that VNI tag, this will go here, this will go here. But you have receiver connected only to leaf 2, not to leaf 3. So leaf 3 will discard it. If leaf 3 is, let's say, or let's say, if I go back to your terminology, RP, right? If let's say the spine is acting as a RP, that means leaf 3 is not even coming into the path. So in case of shared tree, this will not even go to leaf 3. But if it is default MDT, it will go to leaf 3. Because you are configuring, I will show you the config also, that config for default MDT goes under VRF. I will show that config. But when you do that configuration, anything which is coming from customer side will get encapsulated with the IP that you had given for default MDT. And then it just get everywhere. And then because it is not something which we want from efficiency perspective, it is basically a rate specific thing, the traffic rate some specific. Normally customer configure that in kbps, let's say 1 kbps. When they say that when the traffic hit 1 kbps on default MDT, shift the multicast traffic to data MDT. And what they want to do with that, when they shift the traffic to data MDT, that means only leaf 2 gonna get it. Leaf 3 will not. But the question here is, if data MDT is so good, do we need default MDT? The answer to that is yes, because initially your traffic goes on that only. That's how your other receivers and everybody knows about this, that this traffic is coming. All your control plane signaling, let's say, that also travels on default MDT. Okay, so if you see, this is the encapsulation. If I erase this, this is your original packet that you see here. Coming from here, you see these IPs are matching. Then we put this L3 VNI, and then we put this default MDT and my leaf VTAP address. So your traffic get encapsulated. And if I quickly show you the config for this one, see, this is the VRF that you configure, VRF definition green, MDT auto discovery VXLAN, and MDT default VXLAN, this 239.1.1.1. In this case, I haven't configured data MDT, but when you configure data MDT, default MDT, you just configured only one multicast IP address. But data MDT, you normally give a range of, let's say, 8 or 16 addresses, 16 multicast addresses, let's say. That may vary. Why? Because there is one flow, let's say, which is needed between R1 and R2. There can be another flow which is needed from R1 to R4 or R5, let's say. So with the help of data MDT, what data MDT does, it will map that flow 1 to one group, another flow to second group. Outer IP address I'm talking, inner one stays the same. And then R1 and R2, they just sign up for this group. R1 and R3 sign to this group. So second group will not go to R2, first group will not go to R3. Does that clarify?
Yes, it does.
Okay.
Thank you.
Yeah, no problem. These are basically very advanced concept. If somebody is interested, just reach out. I can share some links also. This is interesting as well, by the way, to talk about it, but then we can go on and on and on and on this. Right. So that's why I just wanted to set the foundation for you guys. And if anybody want to dig deeper, let me know. So this we have covered. And then let's just talk about this concept quickly. Many of you had questioned on this RP that I had shown up. You might have seen this concept of distributed anycast gateway, DAG, where you configure the same IP addresses here in Fabric. Any Fabric-based solution you take, BGP eVPN, Cisco ACI, they all support this distributed anycast gateway. That means my gateway will remain same on all these nodes. Same way there is this concept of anycast RP. That means I will configure loopback, let's say 1 as RP here, the same loopback 1 with the same IP as RP here and here. They have the same IP, by the way. Let's take it 1.1.1.1. But here is the important difference. Anycast RP, you may say that Sunil, you have talked about in earlier PIM cases also. But there you have implemented MSDP. Or you might have, we have talked about this also, Anycast PIM also. Nothing like that you implement here. All your leaf nodes act as a RP. That means if the source is coming online, RP is directly connected. If the receiver is coming online, RP is directly connected. And then they sync the information with each other via BGP. That means what I said, no shared tree. Now, in this type of topology, watch the recording if you guys don't remember what type 6 route is, but in this topology, you will not have type 6 route. It is only type 5 and type 7. So if I go back to Shobha's query, in this case, when the source comes online, it will send this type 5. Type 5 BGP route. When the receiver comes online, they had seen this type 5. They know where is the source. They will send type 7 route to join the multicast tree. So if I show this, maybe just allow me a few more minutes and let's just talk about it. We are on top of the hour. But how does the traffic flow work in this? Let's just quickly draw a topology. Let's say source comes online here. This source will start sending the multicast traffic. And then when a source comes online, when it starts sending the multicast traffic, what is the first thing that the source does? Anyone?
Register with the RP.
Correct. Register with the RP, PIM register message. But in our case, this is the RP, right? Each of these node is a RP. This is RP, this is RP. That means this will register locally. When this register locally, what was happening in my previous slide? It will send that type 5 route, let's say. So type 5 will be generated. That means the source is active, but currently there are no receivers. If there are no receivers, and again I go back to my previous point, in multicast, because BGP came here to support certain thing, doesn't mean it will change any of the behavior. What does that mean? That means if you check show IPM route on this node now, when there are no receivers, your OIL output interface list will be null. Now, let's just say that there are certain receiver which comes online. It know type 5 has there on this. This is also the RP. So here locally RP only. So the receiver came online here. It will send a type 7 route. And when this guy receive type 7 route, that means there are certain receivers. What it will do? It will put its L3 VNI here in the OIL. So null will be removed and you will see this L3 VNI in the output interface and your multicast traffic will start flowing. You guys can take a snapshot of this also. And then I have depicted these steps. This is what I have just explained. So this is how basically your BGP help. And this is one model of deployment. A very common model. I have deployed the RP in this way. Anycast RP you can call it, but no MSTP here in this case. It's only BGP for many eVPN fabrics. A scalable and efficient design. But that doesn't mean that you cannot have your RP here, let's say, somewhere internal in the fabric, or only one of the leaf is acting as a RP, not other leaf. That is also supported. Or you can have your RP somewhere outside also. That is also supported. All these are different model. I have explained only one model to you guys. I know this was completely theoretical. If any one of you is interested to dig deeper, let me know. We can see what I can do in this case, because this requires some heavy node to be simulated. And like multicast, I want to spend that effort if there are interested receivers. There are certain configuration. I can anyway send this to you guys if you want, but it is just the underlay. What I mean by underlay, I wanted to show this thing. Your PIM is not going anywhere. Even though we are using MVPN, you still need to configure PIM. You still need to configure underlay RP address. This RP and the RP I was talking previously are two different things. This is underlay RP. Earlier I was talking overlay RP. So this one is overlay RP that I was showing here. So this is the config. And then for multicast on the spine node, you can have this again underlay only. But in underlay, you need to have this MSTP pairing because your MVPN, these things come in the overlay. So when you configure overlay, this is the config that I was showing. And this is your address family MVPN. IPv4 MVPN, rest of the config stays the same. So this is my leaf node config. Feel free to take a snapshot if you guys want. And if I show the complete configuration, then here, this RP that you see here, right? This is that Anycast RP, which is configured on all the leaf node. So I need to configure a loopback, the same loopback basically. And then PIM is not going anywhere, even though we are using MVPN. PIM need to be enabled. This 901 is my L3 VNI. I apologize if some of you are not able to understand this. This concept is related to EVPN. And then this is something that advanced stuff that we are talking. And then the spine configuration. Nothing changes. You only configure this route reflector client. That's it. Same MVPN address family. Here is your L2 VPN, EVPN address family. Okay, so that's how a configuration. If you need it, let me know. Otherwise, I just wanted to show you how does default MDT looks like, how does EVPN configuration, MVPN configuration looks like. With that, I'm done for today.